Greetings and welcome to the basement. In this video, we're going to take a look at data persistence between levels. At some point in your game development career, you are going to want to do the following. You load up into level 1, you do your awesome things, and you get something. Whether it's a score, experience, gold, who knows what it is, but a number has gone up. Or maybe down. And the player's going to want this number to be remembered. However, unfortunately, that is not the default behavior. Number resets every time you change scenes. That is the default behavior in Unity. First, let's understand why this default behavior exists. When you use the standard load scene, you've gone, Unity Engine, .scene management, .scene manager, .load scene, and you've either just passed in an index or you've just passed in a scene name. That's basically the equivalent of going into your project hierarchy here and selecting a scene and loading it. That's what load scene does by default. It discards the old scene and loads in whatever you have on file. And whatever these values are that you see in the editor, that's what's going to be loaded after the scene's been loaded up. So it makes complete sense then that my demo counter gets reset to 0 every time my scene gets loaded. But what if that's not the behavior we want? Maybe I want that score to be persistent. Now, there's a lot of different ways you could go about doing this. I am going to cover 3 of them in this video. I am not trying to imply that these are the 3 best or that somehow other methods are inferior. Nothing of the sort. But at least as far as my mind is concerned, these are the 3 most logical ways of approaching it. And they all have their benefits and their drawbacks. The 3 methods that I am going to cover are using PlayerPrefs, Do Not Destroy on Load, and saving to the file system. Let's start by taking a look at PlayerPrefs. I've already got some framework code set up here. Uncomment that. Nip on down here and uncomment that. PlayerPrefs is a fairly limited system. You can store ints, floats, strings, and that's it. That's all you can do with PlayerPrefs. But with that restriction, it also makes it pretty gosh darn easy to use. So there we go, 218, load into level 2, 218, increase it up to 469, go back into level 2, still there, go back into level 1, still there. Excellent. This is exactly what we wanted. And using PlayerPrefs is incredibly simple, like I said. Literally, this is it. PlayerPrefs has a key that you use to look up the values. So whenever I go to load into the scene, hooked into the start method, I check to see if PlayerPrefs has key score, and if it does, then I get int score. And when the scene is getting unloaded, of course, all the game objects are getting destroyed, so I hook into onDestroy, and I call setInt, pass in the key, and the value. Basically, in programmer parlance, PlayerPrefs is a dictionary. You have a key-value pair. You use the key to look up the value, like a dictionary. A very simple system, incredibly easy to use, and this data is persistent between game sessions. Now, why might you not want to use this? Well, if you're doing a PC build, I would strongly recommend against it, because on Windows 10, this saves the information to the registry. And you don't want to be messing with people's registry, not for saving just game data. You know, for like actually saving preferences like, you know, full screen or not, or screen resolutions or things like that. Okay, yeah, use the registry. That's what it's for. Use PlayerPrefs. That's what it's for. Player preferences. See? But anything past that, yeah, you don't really want to be messing with people's registries. You're probably not going to gunk anything up, but there is that chance, and if word gets around that your game screws with people's registries, say goodbye to people playing your game anymore. The advantage is that PlayerPrefs actually works beautifully on the web as long as you're just concerned about, you know, data storage on that one specific browser. Also, same thing for mobile development. PlayerPrefs works excellent there. So if you've got a mobile game that's got fairly simple save data, PlayerPrefs might be the way to go. Let's take a look at the next method. Don't destroy on load. At the most basic level, it's a pretty easy thing to use. It is a method that's associated with GameObject, and so you can say don't destroy on load, and you pass in the GameObject that you don't want to destroy. So this, which refers to the component, .GameObject, says, okay, my parent GameObject, don't touch it. But you do actually need this additional little bit of logic here. Let me show you what happens if you don't have that. As we hurry up and wait for it to compile. There we go. All right, so we load in just fine. Everything seems to be working a-okay. Then I go into level 2. Oh dear, things seem to be happening. And I go back into level 1, and level 1, and level 2, and oh dear. Oh dear. Something is very not right. I have 5 scores, and I have 5 different null exception messages ticking up at an alarming rate. So what is going on here? Well, let's go back into level 1. Now, when you do a do not destroy on load, it creates this special scene called don't destroy on load, and it shoves your game object in there. And now, regardless of what you do in terms of loading scenes, this special scene here is never unloaded. So I still have score in here. Now the problem, when I load up level 1, there is a score game object in level 1, and so that score game object gets loaded, gets flagged as don't destroy on load, and gets shoved into the don't destroy on load scene, thereby creating a copy. We don't want the naive method. We have to do a little bit of additional logic here. So I'm using a static variable. Again, if you are not familiar with statics, that just means that regardless of how many instances of info demo that I have, there is exactly one copy of this static variable. If I have 1,000 instances of info demo, that means I have 1,000 different demo counters, and I have 1,000 different text boxes, all associated with their specific instance. But I have exactly one copy of this variable that is shared between all 1,000 instances. And I'm pretty much using that as a flag. So when we load up, I check to see if instance is null. And if it is, that means I was the first one to get created. So I am going to go ahead and copy my reference into that variable. So it's no longer null. I'm going to set myself up as a don't destroy on load object. And I'll talk about this in a moment. But if instance is not null, then I know that I wasn't the first. I am not needed. And so I just simply need to be discarded. Now there's another bug that comes into play, and this is why we were getting the null reference exception messages. When we change scenes, the link that we established to this text component gets broken because this text component here, this txt box game object, is destroyed on load. I'm not marking that as don't destroy on load, nor would I want to. I don't want that canvas and text object following me around through all the different scenes. So every time the scene's loaded, this gets nuked because this line only ever gets called once, and exactly once, the very first time it's loaded. So I need a method of detecting when has the scene changed so I know to try to grab another reference. And so that's what's going on here. Scene Manager has this active scene changed event that you can listen into. So I am saying, hey, event, tell me when you go off. And I'm ignoring the arguments. I don't care what scene was loaded. I don't care what scene I was just in. I just care that a scene was loaded. And so I attempt to find a game object called txt_box. And if I find one, if it's not equal to null, then I grab the text component off of it, and I'm good to go. And now this works like we would expect. I did save, right? I did not save. I was expecting a recompile, and the recompile didn't happen. There we go. Business as usual. Oh, yay, and everything's working now. 203. Let's bump that up. 480. Go back into level 2. Still 480. 602. Level 1. Back into level 1. Yay. Values being remembered. No null reference exception errors. And we now have another method of getting data between scenes. Disadvantage to this method is, yeah, well, it's a little persnickety. You do have to put this a little bit of additional logic in here to accommodate for the fact that, yeah, I don't want to endlessly create copies as I go back and revisit scenes. And you have to accommodate for the fact that I'm going to have to somehow, via code, relink any UI elements that I need, because every time the scene changes, I'm going to lose all those UI links. So there's the disadvantage to this. Oh, and another disadvantage. This data is only persistent within the session. The moment the user turns off the game, this data goes bye-bye. It is not persistent between game sessions, as opposed to the PlayerPrefs or the save system that I'm going to show. Advantage. And this is a massive advantage. Its functionality is identical regardless of platform. This is completely platform agnostic. It does not care if you're on Windows, Macintosh, Android, Macintosh, showing my age there. Who uses a Mac now? iOS. Whether you're on an iOS device, Windows build, web, doesn't matter. This works the exact same regardless. So that is its very strong advantage there. It's just not persistent between sessions. Let's take a look at the last method then. And that is the save system. Now, I am not going to go over this class that I have here line by line. In fact, I have a different video in which I do exactly that. So go watch that video if you want to know the nitty-gritty details of this. So let's talk right away about some of the disadvantages to the save system. Well, first of all, there's like a near infinite variety of ways in which you can write information out to a computer. This is just one of those myriad of methods. The other major problem here is that, especially with this one, as I have it written, it only works on a desktop build. It will not work for mobile. It will not work for web. Now, you could get it to work for mobile with a little bit of tweaking, but there's no amount of tweaking that's going to get this to work for a web build. No web server that has half-decent security is going to allow arbitrary programs to write arbitrary files to the web server's file system. It is not going to happen. So if you need persistent data storage on web, you're either using PlayerPrefs or you are using database or some other complex system, maybe using Google Play save, cloud save stuff to be able to remember information. You're going the extra mile in that case. It's just what you got to do for a web build. And just to prove that it works, level 1, go back into level 1. There we go. Excellent. Level 2. And yay, it works. Again, well, simple as far as using it goes. Obviously, writing it, I've got, well, quite a few lines of comments as well. I've got nearly 100 lines of code here. Probably shore that down to around 80-ish lines of code if you took out all my comments. So when I say simple, I mean simple to use. Writing the save data system's not difficult, but it's not trivial either. So I just, on the start, I load up the save system. And every time the scene changes, here we go, on destroy, I make sure I save to disk. Now I am cheating here a little bit. Since the save data, notice I'm not reloading it. The sharp-eyed amongst you might notice, like, wait a minute. Start's only called once. That means you're only ever loading it once. And it's like, yes, you are correct. I'm loading it once. But that's all I need to do because this save data is a part of this component which is never going to get destroyed. So it works. Oh, wait, hold on. I said that wrong. In the interest of not having to re-record a 17-minute long video, let me correct that statement. I am loading it every time. I got myself a little bit mixed up there. I am loading this every time because when I leave the scene, info demo gets destroyed. When I load the scene back up, I'm reloading up that score game object, and we're getting the start method called again. So I misspoke there. I am reloading this every time. So one disadvantage of having 3 different methods in the same class, it can get a little bit confusing, even if you're the one that wrote it. Now, technically, there is another way that we could do this, but it's a method that really deserves its own video because it implies so much more than just persistent data, and that is additive scene loading. We saw a little bit of it with the do not destroy on load method, but Unity will allow you to have multiple scenes loaded at the same time, and not just in the editor. We can do this while the game is playing. So instead of just using the basic scene manager.load scene, we can use the additive load. And we can unload specific scenes instead of unloading everything. So I could leave main menu always loaded and just load level 1, remove level 1, load level 2, remove level 2, so on and so forth. And so therefore, if I never unload main menu, all of the game objects in main menu, well, they stay loaded. They never get destroyed and reset. But like I said, that's an approach that has a lot more implications on the overall design art and architecture of your game logic than just simple basic data transference. I wanted to mention it, but I'm not going to go into details as to how we would make that work, at least not in this video. That is a completely separate kettle of fish. Although, speaking of separate kettles of fish, I've got lots of kettles of fish on this channel, so feel free to peruse the videos. I will hopefully have a video on this one on multiple scenes coming out soon-ish. TM. But regardless, that is all I have to say at the moment for persistent data between scenes. If you found this video useful, well, a like would be appreciated. But if you didn't particularly enjoy it, well, the dislike button is right next to it. And so, until next time.